Okay, today we are looking at finding a missing angle of a triangle, of a right triangle, and then we are also looking at solving a right triangle. Those are the two things we're doing today. We're going to start out on page 227, looking at number 31, and this is the one where we're trying to find the missing angle. So we're trying to figure out what theta equals. Okay? We do everything the same as what we did on Thursday and Friday, and then we've got to do one little tweak to get the angle. So, what's the first thing we want to do? Blake?
You would want to, I haven't a clue.
What did you say? You don't have a clue?
I haven't a clue.
Carson? Alright, but what do I need to do with 7 to 29 first? Christian?
You need to find if there are adjacents or opposites.
I need to identify what two sides I'm dealing with. So Christian, what sides are 7 to 29?
We have the opposite and the hypotenuse.
Alright, so once I identify the two sides, Christian, then I identify what?
The function that we're going to use.
So which trig function do I want? Sine. So I want sine of theta equals 7 over 29. So sine of theta equals 7 over 29. Okay, then here's where something new comes in. Bob, would you have a question? Okay, whenever you're looking for an angle, you have to use inverse sine. So I have to do sine to the -1 of 7 over 29. That will tell me what my angle is. So you'll need to get your calculator out so we can work these. Okay, and again, we want a new document. Stay away from Scratchpad. Scratchpad is evil. So again, where am I going to find inverse sine at? Trig button. Hit your trig button, and then we've got the inverse sine button. And then all I have to do is 7 divided by 29 on the inside of it. Press enter, and it gives me my angle. Now, usually, one question? Usually we want to round, how many decimal places do I want? 3. I usually want 3, but when we're dealing with angles, I only need 1. So in this case, I want the answer to be 13.9. Okay, so my angle is 13.9 degrees.
Oh, okay. So let's have a little circle there.
13.9 degrees would be my angle. So, Nick, what do we do first?
We did the sine and buffer, and then we did the.
Before that.
Before that, we identified what the two sides that we were given are, so the hypotenuse and the opposite.
So, identify your two sides, then what do we do?
Determine the trig function.
Determine the trig function.
And we did the inverse of the trig function.
And then we did the inverse of the trig function. Very good. We only use the inverse of a trig function when we're looking for. What were we looking for in this problem?
The other angle.
The angle. We only use the inverse trig function if I'm looking to find an angle. If I'm not looking to find an angle, it's going to be the regular trig function.
Okay.
Who had their hand raised?
That you just answered my question.
All right, next one. All right, 35. I've got my angle I'm looking for, and they have given me two sides. So gauge what I want to do first.
You want to take the, I don't know. I don't know.
Matt?
You want to figure out what sides you're dealing with, like is it the hypotenuse, adjacent, all that.
Very good. So what two sides am I dealing with here?
Dealing with the opposite one and the adjacent.
All right, and then that leads into what?
Whether you use sin, tan, or cos. I know it's abbreviations, you don't like it, but
Sine, cosine, tangent.
He said.
So which one of those do I want to use?
beyond that, I do not know.
Kathleen, which one do I want to use?
Got opposite and adjacent, so tangent.
I want to use tangent. So we do tangent of theta equals 10 over 6. All right, once I have that set up, Kendrick, what do I do next?
So you
Take the inverse. So I have theta equals inverse tangent of 10 divided by 6, and that will give me my angle. So trig inverse tangent 10 divided by 6. Press enter. 59.0. So my angle is 59.0 degrees.
Do we have to put .0?
I want the point 0, yeah.
Wait, correct.
All right, let's do one more like this, and then we'll get into solving the triangle. So here's my next one. I've got two sides, 7 and 12. So Reagan, what do we do first?
To find the sides.
All right, so what sides am I dealing with?
The hypotenuse and adjacent.
All right, and that leads into my next decision, which is
Which problem you're using.
which trig function, and which one am I going to use? Cosine, good. So we're going to do cosine of theta, and I get 7 over 12. Now, when you're setting up sine or cosine, what always has to be true about your fraction? Has anybody noticed that?
The biggest one is on.
The bigger number is always on the bottom whenever you're dealing with sine and cosine. Which means if you're dealing with secant and cosecant, what has to be true? Bigger number has to be on top. Okay, so that helps with those two. Now, on tangent and cotangent, it's not that way. Bigger number could be on the top or the bottom on tangent and cotangent. But on sine and cosine and secant and cosecant, that should always happen. Rachel?
So on these, could you have it be cosecant?
Yes, you can do cosecant if you want to. But I like to teach sine, cosine, and tangent because we're a lot more comfortable with those three. All right, so then I need the inverse. So I want inverse cosine of 7 over 12. So take a trig, inverse cosine, 7 divided by 12. Press enter, we get 54.3. So my angle is 54.3 degrees. So any questions on solving for an angle when you're given two sides in a right triangle? Rachel?
Could we get the same answer if we did cosecant?
Yes. So if it's or what did you say? Cosecant? No, it would have to be secant. So if I did secant, it would be 12 over 7, or theta equals inverse secant of 12 over 7. So I go to my calculator and I choose trig and I do inverse secant. Inverse secant of 12 divided by 7. I should get the same answer. There it is. Alright, so that is solving for an angle given two sides. Now we want to just straight up solve a triangle. So what do you think it means whenever I want to solve a triangle?
Figure out everything about it.
Find everything. Find the missing sides and find the missing angles. That's what it means to solve a triangle. So you will usually be given two things. You'll be given an angle and a side, or you'll be given two sides. That's usually what you're going to be given. From that information, you need to find everything that's missing. Now,
technically, can we, since this one is giving us, wouldn't this one be giving us like two angles and a side because it's a 90-degree at C?
we can find the second angle very easily, yes.
Yeah, okay.
All right, now I want to point out. Somebody knock. I want to point out. Make sure you notice how these triangles are labeled. What do you notice about the uppercase letters?
There.
The angles. The angles are always your uppercase letters, and what do you notice about your lowercase letters? They're your sides. And then what do you notice about an uppercase A and a lowercase a, or an uppercase B and a lowercase b, or an uppercase C and a lowercase c?
They're opposite.
They're always opposite of each other. Whenever you're setting up a triangle, the uppercase letter and the lowercase letter should always be opposite of each other. Okay, and if you're dealing with A, B, and C, C is always your right angle. So C is always your right angle whenever you're setting it up like this. So, what three things do I need to find here?
The other angle.
I need angle B. I need what?
Side B.
Side B and
Side C.
side C. Those are the three things I need to find. Of those three, what's the easiest to find first?
Angle B.
Angle B. What does angle B have to be?
70.
Has to be 70 degrees. What do we do to get 70 degrees?
120 plus 90, 180 minus 110.
Alright, that's too much work, Blake.
Oh.
Yes, that'll get the job done. All I have to do is subtract 20 from
90.
90. You just have to subtract it from 90. What Blake said will still work, but it's a little bit more work. Alright, so then I have my other two sides that I need to find. Now, 90% of the time, you never want to use something you have found. For instance, I just found B, angle B. I do not want to use angle B to help me find something else. There are two reasons why I don't want to do that. What two reasons do I not want to do that?
In case you're
In case I screwed up finding it, and the other one is, what do we usually have to do to our answers when we're dealing with a triangle?
Check.
What do you say?
Check them.
No, not check them. Because we usually have a bunch of decimals. What do we use? We usually have to round. So I don't want to use a rounded answer to find another answer because that makes it less accurate. So for those two reasons, you don't want to use something you found to find something else. Now there is one exception to that, and you'll see that here in a little bit. So that means I do not want to use angle B to help me find side B or side C. So let's work on finding side B first. Who can set something up for me to help me find side B? Christian?
If you use angle A, so 20 degrees.
20 degrees.
Already established.
Correct?
And we can find that B is the adjacent.
B is the adjacent.
Of 20.
Correct.
And we can use 6 as the opposite.
Correct?
So that would make it, what is that? Is it cosine?
Not cosine.
Tangent?
Tangent. So I want to use tangent of 20 degrees, and that would equal 6 over B. So it's the same thing we've been doing. Identify two sides you want to deal with, set up your trig function, and then solve. That's all we're doing. So since I'm solving for B, what's my next step need to be? Switch them. So I have B equals 6 over tangent of 20 degrees, and then I punch it in my calculator. So control divide, I want 6 over, was it tangent of 20? Press enter, so we've got 16.484. So 16.484 is B. Now I'm interested in finding C. So I want somebody else besides Christian to help me set something up to find C. Kurt?
Sine of 20 equals 6 over C.
Sine of 20 equals 6 over C. Now, what was your thought process on being able to find that?
I'm just trying to find C, so use sine.
Haley, what should his thought process have been?
That's what I just.
You're just that good. You can just look at it, just wham. There it is. Tarson,
Wait,
Like,
you can say no. You can say it.
Pythagorean's theorem.
you want to use Pythagorean theorem? What's the only problem with using Pythagorean
The
theorem?
round
There
and
is no
round.
You have to use something you just found. That's why we don't want to use Pythagorean theorem.
Well,
Kathleen,
I always label what it is. So we discovered for C we need the hypotenuse, and we have the opposite. So we know we have opposite and hypotenuse, which is sine. So
that's what I wanted to hear. I'm dealing with the side that is opposite, and I'm dealing with the side that's hypotenuse, and that tells me sine. That's what I want to hear. Identify your sides first, set up your ratio, and then solve. So again, I need to switch. And that gives me that. So I punch that in. What was it? Control divide. It was 6 over, what was my trig function sign? Sine of 20. I press enter, so 17.4 or 542. 17.542. Now what's something I can do real quick? and make sure what I have found makes sense.
Make sure that C is bigger than the other one.
Make sure that C is the biggest side, and
Make sure that's not related to the angle measurement.
make sure that B, how does B need to be related to the other side they gave me?
It needs to be bigger than the
Because
angle is bigger than
the angle that goes with B is bigger than the angle of 20, so that means side B has to be bigger than the side that goes with 20. Very good. All right, let's do one more. All right, 49. 49, they give me a triangle. This time they've given me two sides. And I need to find the three missing items. Bree, what would my three missing items be in this case?
Side R,
Side R,
angle Q,
angle Q, and angle P. Now, somebody tell me something about angle Q and angle P.
They have to add them up here.
They have to add up to equal 90. Caleb?
Aren't they equal to each other?
They're not equal to each other, but they should be what? They should be close. Why should they be close, Bailey?
Because 25 and 23 are very
Because 25 and 23 are close. So that means they should be close to what angle measure? 45. They should be very close to 45. One should be bigger. Angle Q should be bigger than 45, and angle P should be smaller than 45. Everybody agree with that?
Yes.
Good, good. All right. So, Bobby, what do you want to do first?
We can find R.
We can find R. What do you want to do to find R?
We can go Pythagorean theorem.
This time we can use the Pythagorean theorem. Why are we allowed to use it this time?
Well, because we already got two sides.
Because they gave me two sides. Outstanding. And when I use the Pythagorean theorem, Bobby, what do we need to? What's the biggest thing to identify? Quit helping her. The hypotenuse. What is the hypotenuse in this case?
Is it R?
R. So that means R has to be over here by itself. And I've got 23 squared plus 25 squared over here. And you can give me that answer in one of two ways. We can do 23 squared plus 25 squared and give me that. So you can give it to me as the square root of 1154, or you can actually give me the decimal. So I do square root. Oops. So square root of that answer. And 33.970. Okay, do we think 33.970 is okay?
Yes.
Why?
Because it's bigger.
It's bigger than the other two sides. Good. So now I need to find angle Q and then angle P. So let's find angle Q first. AJ set something up for me to find angle Q.
You have the opposite angle for the opposite side.
Opposite side and
And hypotenuse.
I don't have the hypotenuse.
Well, we want to find it.
I've already got the hypotenuse. I'm looking for an angle. And if I'm looking for an angle, I've got to have two sides to deal with. So I've got the opposite side. What else? What other side do I have?
The adjacent.
The adjacent. So I know I've got the opposite and adjacent, which tells me to deal with what trig function?
Sine.
No. Tangent. So I want tangent of Q equals 25 over 23. And since I'm looking, Colleen, since I'm looking for an angle, that tells me I'm going to use what? I'm going to use the inverse. Very good. So I have Q equals inverse tangent of 25 over 23. So I do trig, I do inverse tangent of 25 divided by 23, and that gives me 47.3. Just a second. Okay, and just like we said Q should be slightly bigger than what? 45, and it is. Matt?
Why did you choose to use inverse tangent rather than regular tangent?
Because I was looking for an angle. If you're looking for an angle, you have to end up with inverse of whatever trig function you're doing. Now, here is the one exception that I talked about earlier, that we didn't want to use something we found, and we didn't want to use something that was rounded. This is the one exception where I do want to use something I found. Why? Why do I want to use the angle I found to find the other angles? Because if I'm dealing with angles of a triangle, they must add up to 180 degrees. So if I find one angle, I have to use that angle to find the other angle. So Blake, what do I want to do with Q to be able to find P?
You want to subtract it from 9.
I want to subtract it from 90. Very good.
Oh, okay, that's kind of deleted.
So 90 minus 47.3.
42.7.
So I get 42.7.
I is on my calculator.
I think.
So I get 42.7, which is slightly smaller than 45, just like we said it should be. Rachel,
Can you do it that way?
you can set up another trig ratio to find it.
Would
But when
it still be opposite or adjacent?
If I was to find P, yes, I would still use opposite over adjacent.
We can switch the numbers instead.
Except these two, this time it would be P would equal 23 over 25. So I get inverse tangent 23 over 25. And I punch that in there. So trig inverse tangent 23 divided by 25. Press enter. We get 42.6. But I need it to add up. I need it to add up to 90, so I've got to make it 42.7. So I'd really take two different answers on this one. You could make this one 47.4, and you could make this one 42.6. So I'd take either one of those. But you've got to make sure your angles add up to 90. So when I am solving for an angle, or I'm just solving a triangle, what do we want to do first? Identify the sides. Once I identify the sides, identify the trig function, set up your ratio. The only time I use inverse sine, inverse tangent, or inverse cosine is when I'm looking for an angle. If you're not trying to get an angle, do not use an inverse, because that's something you guys will get confused on. Only use an inverse if you're looking for an angle. Okay? Alright. Assignments over here on the board. Number 3, page 227, 28, 32 to 40, and 48 to 54.
That's what you need.